Hello, and welcome to a lesson on the purpose and uses of fprintf function. I'm your instructor for this module, Mark Earl. The objectives for this lesson include learning the purpose and basic uses of the fprintf function. Secondly, to understand some of the common format specifiers, and we'll explain what that is in a moment. Also, I want you to know where you can find additional information if so inclined. The purpose of the fprintf function is that we want to be able to write textual information to a file. Here, a file can be a screen, such as the window that we're going to be printing out to, or a named storage location on some physical or virtual drive. This would be some file that you might create to hold regular text, or it could be something that's going to hold a series of numbers, some type of data that you're trying to output, etc. The textual information can be a string of characters like we would normally type on the keyboard, but it can also be variables in a program that contain characters, integers, decimals, etc. If you're interested in learning about the ways in which variables can be modified in how they are presented to a file, you can see my lesson on fprintf formatting. So the basic uses of fprintf include, as shown here, a function that you would call in your C program in which you would pass a file stream. This would be a pointer to some file that has already been opened, followed by a string. And notice while I have this written on 2 lines, they can be on 1 line in your C source code file. The string is going to be either a double quoted string or a pointer to a string in memory. The fprintf function itself is part of the C standard input-output library referred to as standard IO or stdio. Here's 2 examples of the fprintf function. The first one, we're actually passing the string directly by typing text information in between the double quotes. In the second example, we're declaring a character string. So this is a pointer to a string or a sequence of characters that have been defined to hold hello world. And then we're able to just refer to that variable string in our fprintf function. Now notice here that in both of these examples, we're using standard out as the file. There are 3 files that are opened automatically for you whenever you execute a compiled program. One of those is standard out, which by default would be our screen or terminal or console that we're using to run the program. We also have something called standard error, which is typically reserved for receiving information indicating some type of a problem or carrying some diagnostic information. By default, both standard out and standard error are the same output location, meaning the console, terminal, or screen in which you're executing the program. But also the file can be standard in, which would be if you were to enter information from your keyboard through the console, terminal, or screen in which you're executing. So just to keep things simple, I've just shown how we want to print something to standard out, which by default is your screen. But just know that you can also open up other files that might already exist in your file system, say on a thumb drive or on a hard drive, or they could be one that you want to create to be placed on there. In any event, or in both of those events, the file needs to be opened ahead of time before we can use it. So as far as the alternative form, so we saw the first one just had a file stream followed by a string, but know that we can, within this string, we can include one or more format specifiers. And then if we have one or more format specifiers, for each one of those, we need to have some variable or replacement item specified. And this will be clear in the example in a moment. The format specifier specifies the type of the item and any additional specifications, such as formatting that we would like to control the appearance. Let's say that it's a number with an exponent. And do we want that exponent to be represented with a lowercase e or uppercase e, like in scientific notation? And there's other formatting options as well. Again, you can see the lesson on C fprintf formatting to learn more. So let's take a look at the example that I have shown here. So in this case, we're declaring a variable called character, and we're initializing that to contain the exclamation point. And then in our fprintf function, things look pretty similar to what we saw earlier, except now we have this %C. So this is what we call a format specifier. And the C here means that we're expecting some character to be placed in this location in the string. So immediately following the character D in hello world, we're expecting some character to be passed to the fprintf function. And in this case, we're passing the variable name character. So we would expect hello world exclamation point to appear on our screen when we compile and execute this program. Alternatively, we could create an entire string, which would be a pointer to multiple characters. And here I have this initialized to be world followed by the exclamation point. And so slightly different than the earlier example, I have hello, comma, %s, which is the format specifier indicating that a string needs to be passed to replace that location in our string that we specified here. So I pass string to be placed where %s is located. And I actually will show us later an example of some code running so you can see what this output will look like. We'll revisit these in a few minutes. So what are some common format specifiers? Well, two that we've already looked at are the character and the string, and I have some examples on the right-hand side here. But then also we might want to print out a signed number or decimal number, an integer, for example. And so here I have the C data type of int for integer, and I'm initializing that to -5 or -5. And then let's say that I have a number in scientific notation. It has some fractional value to it. And here I show that using the float data type, and I've initialized it to 6.022 times 10 to the 23. And this other one is kind of unique, this last one, where I have %%. Well, because we're using % as a special purpose character in our original string, how would we go about printing out a % sign? Well, the way to do that is to actually specify % followed by %. And here there's nothing to replace because this is actually kind of specifying that we're not looking to replace this, we're actually looking to print out the percent sign. So that's kind of an unusual case, but perhaps you can understand why that's needed. So let's take a look at some code. So I have some here in this directory, and I'll make this screen just a little bit larger for us. So if I open up the fprintf examples.c file, you can see at the top that I have this pound include, which we didn't talk about. But what this tells the C compiler is that it's supposed to look or include the standard IO library so that we have access to the fprintf function. And here's the start of our code on line 3, or the start of our main function, I should say. And in there, I'm declaring some variables. We have a variable C, which is a character, and that is initialized to the exclamation point. We have string 1 holding fprintf is. We have string 2 holding cool. And then here we have an fprintf statement. So I'm printing the standard out like we did in the earlier examples. But now look, I have several different format specifiers. I have %s, meaning some string is going to be placed here, followed by 100, and then %%. So this is going to be turned into 100%, followed by another string, followed by a character. So this is expecting 3 different variables, or 2 strings and a character, to be passed in. And that's what I'm doing. I'm passing string 1, string 2, and the variable C. I also have something we didn't talk about, and that is /n, which is a special control character that says print a new line. And I'll move myself out of the way so you can see the rest of that comment. And then I follow up with another example where I have some integers being declared. I1 is 2022, I2 is 2011, and then I have a floating point number, meaning it contains an exponent, and that's set to 6.022 times 10 to the 23rd. I have my fprintf statement where I have quite a long string with 2 items being replaced. I have a integer or decimal that needs to be printed out. And then I have this format specifier for a floating point number, a number with a fractional and or exponent value that needs to be replaced. And I'll make this a little bit smaller so we can get this on one line. That's pretty close. So in the first case, I'm not just passing one variable, I'm actually doing some arithmetic here. I'm going to subtract I2 from I1. So we're going to subtract 211 from 2022. And then I'm passing this float variable f. So let's jump out of this code and compile it. So I'm using the GNU C compiler, but any modern C compiler should work fine. This is going to give me a executable called a.out. And so I can execute that to see the output. So the first fprintf statement prints out fprintf is 100% cool. So you can see that percent that came out as a result of the %% specifier. And then here's the result of our subtraction. So it turns out in 1811, Amedeo Avogadro discovered the number of particles in a mole, and that is 6.022 times 10 to the 23rd. So if you're interested in learning more about this, I encourage you to check out the man page, which is the Linux manual available on your MacBook or Chromebook or any device running Linux. You can also search on man fprintf, and oops, sorry about that. And that will bring up the man page from within your browser. If you should specify, or I should say, you should specify chapter 3 of the manual, which is what this second argument is, or this, sorry, the first argument to the man command. And that's going to indicate chapter 3, which contains the C commands. You can also search for a variety of tutorials online, as well as some examples by using these search strings. There's also a short YouTube video, which I have shown here. And this one actually includes the opening and closing of a file. So whereas I used standard out, this we would be able to see how we could open up a file like on a thumb drive or on a hard drive. So again, our objectives were to learn the purpose and basic uses of the C fprintf function, to understand some of the common format specifiers, and know where to find additional information.